this video we're going to look at a histogram problem which tests whether you truly understand how to work with the fact that the area is equal to the frequency. So first of all, we notice that there's information missing in the frequency column and that there's some bars missing over here. So what I'm going to do is match up my classes with my bars to see what I need to do. Okay, and the first thing we're going to do is work out where there's a bar that matches data. So here we have data and we have a bar. We also have data and a bar here. I'm going to use this one here because it's got some nice numbers, frequency of 10, and we're going to work with that bar there. So what we got is, I've zoomed in on that bar, and remember that the frequency is equal to the class width times by the frequency density, and the frequency density is the height of the bar, and we want to find out the height of this bar. So remembering that frequency is equal to the class width times by the frequency density, we can see we have a frequency of 10 and we have a class width which is equal to 100 minus 75. So that class width is 25. Times that by frequency density and we get our equation. So 10 divided by 25 equals the frequency density. So we can see that is 0.4, which suits our scale nicely, because if you notice you've got 1, 2, 3, 4 little squares, so each one is going to be 0.1 high, and the height of our bar is 0.4. So I can fill in that bar there for the frequency density of 0.4. Let's go back to our table and our graph. So we now know that this here is 1, 2, 3, 0.4 high. So this is 1, 2, 3, 4, 5. So that point there is going to be 0.5. And we can now fill in the scale. And I suggest you always do this. Now sometimes they'll have a frequency density that wouldn't be necessarily the same as this. Okay, and sometimes they might have these all double, because actually the frequency only has to be proportional to area, not equal to area. I suggest in those cases you change the scale using the method I just shown and write your own scale in so that the frequency equals the area and everything else becomes much easier to do from there. Let's put that back into here. So we know our frequency density here is 0.5 and we know that the class width was 20. So therefore 0.5 times 20 will give us our frequency. So that will be 10. And then if we move on to the next question, part of the question, well, let's just fill in all the ones where we don't know the frequency first. So let's do this one. This one's 20 wide as well. And we can see this one here is 1, 2, 3, 4, 5, 6, 7, 8, 0.9 high. Actually, while we're here, 1.0, 1.1, 1.2, 1.3 high is the height of that bar. So we have got a class width of 20 times by 0.9, and that will give us a frequency of 18. And just to check this is all working, look, that bar is 10 times by 13, sorry, times by 1.3 will give us the 13 here. Now all we've got left to do is to find out the green bar and to find out this sort of mucky yellow bar here. Okay, so we're going to try and find out the heights of those. So remembering that the frequency equals the class width times by the frequency density, we can rearrange that to show that the frequency density is equal to the frequency divided by the class width. So frequency here is 15, divided by the class width, which is 10, gives us a frequency density of 1.5. So we can zoom into our graph, realise 1, 2, 1.1, 1.2, 1.3, 1.4, 1.5, and we get that bar there. Let's color it in nice green just to make sure we can see where it is. And then if we go to this one here, we can see we got 15, and we've got to divide that by a class width of 15, so that is equal to 1.0. Remember, the class width 75 minus 60 equals 15, so the height of this one is 1.0. So let's just rub that out a bit and draw this in, color it in the same color, and we can see we have our histogram finished. Just for completeness, let's just work out these frequency densities. Let's just check they all make sense with the diagram. So here we've got 18 divided by 20 is 0.9. Here we've got 13 divided by 10 is 1.3. Here we've got 10 divided by 25, which is 0.4. So those all match up with my heights of all my bars. 0.4 here, 1.0 there, 1.5 here, and obviously 0.5 here.